All right, guys, it's your last lesson of the week, lesson 3 for 8-2. I wish you could see right now when I said, all right, guys, I just freaked Elliot out. He just jumped out of his bed. That was pretty hilarious. So anyway, today we are measuring angles, and this is going to be way hard for you to do from home because you don't have a protractor. So I want you to know that my plan basically is for you to try some of this out at home, but know that an IXL lesson to do this practice is going to be a good idea since you don't have a handy protractor nearby. I also want to let you know that this lesson has been split up into 2 parts, so just make sure you know we're only going to do part of that one today. So let's go ahead and dive right in. As you know, we're talking about geometry, and one important part of geometry is like measuring a circle or a triangle or a polygon of any kind, and you have to do that by using something they call degrees. Now that doesn't mean degrees Fahrenheit or degrees Celsius, which is like temperature. This means degrees of a measurement tool in order to find a circle or anything like that. So this says angles are measured in units called degrees. 1 degree is the measure of one very small turn from one ray to the other. I'm going to give you a quick overview. Basically, in a circle, there are 360 little ticks that you can make across the entire circle, so we say that there are 360 degrees altogether. And if you think about what's going on here, if I were to make a 90-degree angle, and then do another 90-degree angle, and then do another 90-degree angle, and then finally my last 90-degree angle, well, what's 4 groups of 90 degrees? That's 360. Okay, so that's just a little jump ahead. You don't actually need to know so much of that information today. But what you do need to know is that an angle can have a measure of, this angle right here has a measure of 1 degree. And then we can basically make 5 little tick marks up, and this is what your angle will now look like, and we say that it is a 5-degree angle. So the most important part about angle or degrees today that I want to make sure you understand is how to write them. It's kind of fun, I think, and it's also the same thing if you're doing temperature. But if I was going to tell you or label that this angle had a 5-degree angle, I basically write my number 5 like normal, and then you have a tiny little raised circle that has to be open. Okay, so it's a little tiny open circle that stands for degrees. Okay, so again, that's a 5-degree angle, and that's kind of how you write it. So it says a right angle has a measure of 90 degrees. A 90-degree turn traces 1/4 of a circle, kind of like what I just showed you a second ago. So they're telling you that if you were to measure all those little tick marks along the way, there would be 90 of them until you got to a 90-degree angle, or what we also call a right angle. And then we also have something called a straight angle. We also call it a line. So a straight angle could go on forever, but if you were to measure its arc, we kind of call that an arc, that would be 180 degrees. And then an entire circle has 360. In 4th grade, you don't actually deal a lot with circles because they're a little bit more confusing. So I wouldn't worry about that one too much, okay? But let's talk today about how to use a protractor. Well, good news for me is that I actually have a protractor that I can use here. Elliot, we don't need your commentary. Woo! We definitely didn't mean to do that. Let me try to move this guy. Make it a little smaller, and then I'm going to move it over, okay? So a protractor is this really cool tool that they use in geometry, and a protractor, it basically helps you measure any sort of angles or in degrees, okay? So this protractor right here, this is an angle, I'm not sure if you can see it, but this is angle ABC. So A endpoint is here, your B vertex is right here, and then your C endpoint is right here. So you've got ray BA and you've got ray BC. And I can now measure to see with my protractor what exactly the measure of this angle is. Well, I'm going to use my protractor over the top of this. I know it's going to get a little confusing. And I can see right there, do you see the red line underneath it? I can see that this angle measures exactly 90 degrees. So we would say that this angle right here has a measurement of 90 degrees. Okay? But let's look at number 15. Or sorry, that's my page. Let's look at questions 1 through 4, and they want you to measure each angle with a protractor. Well, this is where you're going to have to kind of just watch me go through this because you do not have a protractor nearby, and that's okay. So what we do when we use a protractor is you want to drag it, and do you see this little part right here where you've got a line going up and you've got these lines to the side? You want this to kind of magically rest right on top of your line. So here's what I want you to notice. This is hard for me to do on a computer video and not in person. But if I were to put this over here, you can see that this line right here isn't matching up with my end point. So I need it to perfectly match up with my end point. So I'm going to now just draw, and I'm going to drop that and leave it right there, okay? Now, I also have this handy tool on mine that you guys don't have this on a regular protractor. On a regular protractor, what you would do, just follow my little dot here, is you would follow this second part of my ray all the way up to see that it matches with the numbers 70 and 110. So we got to figure out which one's correct. Here's where this will kind of come in handy. So for me, I can take this, for me, I can take this tool and I can actually drag to see where this will end, and it's going to show me that it ends right there on 70 degrees. I left it a tick off just because of space. So that tells me that the angle of KLM is actually 70 degrees. Now I want to talk to you about how I knew that it was 70 and not 110. If 110 is going to be greater than 90, and I don't know if you guys remember listening to me talk to you the other day about a right angle, but a right angle is exactly 90 degrees, and anything that is greater than 90 degrees we call obtuse. And then in green, I'm going to show you this guy, but anything that we label that is less than 90 degrees, let's say that this was 30 degrees for whatever reason, we would call that acute. So over here, when I did my angle measurements, I can see that this is an acute angle because it's less than 90. So because of that, I know that 70 came first, or 70 is the correct answer. I can also tell because on my protractor, the first number you come across is the angle, is your actual angle. So that would be this 70 right there. Okay? That was bothering me. All right, so now I'm going to erase a couple of things, get you out of the way. But 70 is the correct answer, and now I'm going to move this guy over to here. So now this time I've got something different going on. Something that might be helpful first is for me to ask myself, what if I were to first figure out whether or not this is an obtuse angle or an acute angle? Well, if I take my little 90-degree tester, remember you can use a 90-degree tester by using the side of a piece of paper, but I'm just going to use this little square. And I can tell that my angle is going to be more than 90 degrees because it's more than this shape right here. So I already know that this one's going to not only be greater than 90 degrees, but that we'd also call it an obtuse angle. So I'm going to bring this back up. This time, I need my little arrow guy here to be on the other side, and it's not going to do it, so that's fine. So I want you to notice that we're going to follow this line all the way up. And you see here how we reach that 70 again, but I already just figured out that this is technically supposed to be greater than 90, so that must mean, what is it doing? That must mean that my, my answer is 110 there. I'm trying to be too fancy with my protractor, and it's not going very well. So I can tell that that answer right there is going to be 110 degrees. So let's go ahead and move this one. Now this is going to be a little bit tricky. Look at number 3. My protractor is not doing the right thing right now. But that's the good news with a protractor is I can twist mine. Maybe if I can figure this out. There we go. I can twist mine so that I can try to get it to follow one entire ray. And I can tell that I'm not totally there yet. But I'm going to keep twisting a little bit. And now I think I'm good, okay? So, let me do that. Okay, there we go. So now I can already tell that this was an acute angle. Let me move that out of the way. This you can tell is an acute angle because that's very small. So I know that I'm looking for a number that's less than 90. So I'm going to stack back up my protractor here. And I want you to notice here that you start with 0 degrees. A line would be here, 0 degrees, and then I'm going to go up 10, 20, and look where this ends up. It's either going to be 30 or 150, and like we just said, this is really small. So 30 degrees makes more sense. And now I need to twist that around again. And I'm going to finally look at this one, and I want you to notice here, do you see this 30 degrees? Or what? Do you see this angle right here is really big? It's really open, and if I were to drag over my little 90-degree tester here, I can see that it's going to be way bigger than 90 degrees. So that's going to help me when I use my protractor. Let's drag it on over. And I can see that if I follow this first line, that goes 0 to 150. So this line right here is going to be 150 degrees. So I also want to show you a little bit quickly how you could use these to draw. And I'm not going to do 90 degrees because 90 is super easy. You just want to follow your lines and make that a 90 degree. Think about it as like part of a square. But for 45 degrees, I would need to have my protractor back. And I'm going to show you, gosh, maybe insert measure tool protractor. Okay, there we go. For me, if I was going to draw a 45 degree angle, it's kind of hard for me to do on this computer. Again, in person with an actual protractor would be way easier. But what I want to show you here, I'm just choosing a random spot to be on. I want to shrink this quite a bit. And then I want this to be a 45 degree angle. So that shows me that I would like, come on, you can do it. There we go. I would like to make this 45 degrees. Oh gosh. This is not going very well, guys. I apologize. I want this to be 45 degrees. So if I were to go like that, that's going to be exactly 45 degrees, and then that would help me draw. I'm realizing that this is almost impossible to do on a on this computer without actually having protractors in my hands with you guys. So I'm actually going to skip the rest of this page, and that is totally fine. Don't worry about doing this page today. It's not going to be a big deal. If you see it in the IXL, they'll be able to have ways for you to practice this skill. So I'm going to actually come over here to 9 through 13. This will be a good use of our time. It wants you to use this little figure to the right in order to answer some of these questions. So one thing it wants you to name is a right angle from this figure. Well, remember, a right angle is going to be a 90 degree, and I see two examples right here. Why don't we do this one? So we'll call this one MRK. So we would name that angle MRK, and again, because that makes a 90 degree. Now it wants a straight angle. Remember, straight angle is basically a line. So we could do BRK because that's where your straight angle is. So BR and then K. For number 11, it says how much greater is the measure of KRB than the measure of IAO. So here's IAO, and then it says KRB. Well, here we've got 180 degrees for a line, and then our right angle is 90 degrees, so the difference between those two is just simply 90 degrees, okay? And then it says which angle appears to be a 45 degree angle. Hopefully that's just a visual one for you to see. I also think about it like this. Half of 90 is 45, so that should be half of a 90 degree angle would be this line here. So we could say that U, A, and E would be a 45 degree angle. Okay, so we're going to skip number 13. You don't have to worry about that one right now. So that's a quick overview. Like I told you, we're going to do more with this work on Monday when we come back, and this will make a little bit more sense. So today, I actually think that I would like you to try to check out some IXL lessons for this week. So go check out what the options were for 8-2, part 1. Also, if you didn't get to any IXLs, you could go do 8-1 IXLs, because these geometry terms are kind of tricky, so it's going to be a good idea to really understand this vocab. So I would probably recommend today to do some IXL work on either 8-1 or 8-2. Otherwise, log into Zoom if you're needing some help.